Students, you are welcome to chemistry class. This morning we are going to be looking at electrochemical cell. The topic we are considering this morning is electrochemical cell. Electrochemical cell can simply be defined as a device which converts chemical energy into electrical energy. A device which converts chemical energy into electrical energy. Electrochemical cell consists of two half cells, and each half cell is consisting of a metal strip deep into a solution of its salt. A metal strip deep into a solution of its salt. And when we have that, like we have on the board, this is an example of an half cell. A zinc electrode or zinc plate deep into a solution of zinc tetraoxosulfate solution. And this is our electrolyte. This is the container, the beaker, and this is the electrode. So an electrode of zinc is constituting an half cell. So when we have another half cell joined together by a porous partition or a salt bridge, that will constitute an electrochemical cell. Now let's look at the diagram we have on the board. This is an example of an electrochemical cell. Here we have two half cells of zinc and that of copper. The zinc half cell contains the zinc as the anode. The anode here is the negative electrode, while the cathode is the positive electrode. Remember that in our electrolytic cell, we have anode as the positive electrode, but in an electrochemical cell, the anode is serving as the negative electrode. And also the reaction that will be taking place at the anode is oxidation reaction. While at the cathode, the positive electrode here is we are going to have our reduction reaction. Now if you look at this setup, we have both the anode and the cathode inside a container. We have them in separate half cells. That is, the electrolyte of the anode and the electrolyte of the cathode, they are separated, not together, but being connected by a porous partition. The porous partition will only allow the flow of ions and for the cell to be completed. Now when we have the flow of electrons through the electrode, that will constitute the current flow or the generation of electric current. Don't forget, we have a device that will convert chemical energy into electrical energy. So the two electrolytes we are having in the cell, they are chemicals, and when they are connected, they are going to generate an electric current. Now for each half cell constitutes a metal strip deep into a solution of its salt. Now when we have that equilibrium between the liquid ion, the liquid phase and the solid phase going to the solution, and is going to release electrons. Now we want to represent this as something we call cell notation. Like your metal, the solid metal, now this is how we write the reaction taking place at each half cell. You have your metal, you have the slanting line representing the interface between the solid and the liquid or the ion state of the cell. So depending on the number of ions being released by the metal is our N. Now if you look, we come back to the electrochemical cell. We said here we have zinc as the anode and copper as the cathode. Now the reaction that we are going to have at the anode is oxidation. You see zinc here going into the solution to release two electrons from zinc metal to zinc ion, and that is oxidation. Oxidation is loss of electron, while at the cathode we have gain of electron. You see the copper ion gaining two electron and to be deposited at solid metal. So majorly those are the reaction that we have in an electrochemical cell. At both the anode and the cathode, you must be able to express the reactions at both electrodes by oxidation half reaction. That's half equation for the anode and the half equation at the cathode. Don't forget, our electrochemical cell is a device which converts a chemical energy into an electrical energy. Like the normal transistor radio battery is an example of an electrochemical cell. The lead acid accumulator is also an example of electrochemical cell. Electrochemical cells can be classified into two. We have primary cells and secondary cells. Primary cells and secondary cells. So this is where we are going to end the lesson. We'll continue from here in this class. God bless you.